And good morning again. Voices of Success, that's the title of our next session. Here we will hear from some examples, Gaia-X based solutions or existing solutions which are on the way to become Gaia-X compatible. And let's start with this. And for the first presentation, I would like to ask Petteri Kivimäki on stage. Petteri is from NIIS from Finland, and working close together with the guys in Estonia. I had the pleasure to visit Estonia, I think 4 years ago, talking to a lot of people there, talking to the CIO of Estonia, and it is simply impressive what they created over the last 20 years. And is it X-Road or Crossroad? How do you?
It's X-Road.
X-Road.
Yeah.
So X-Road, what X-Road as the basis for the digitization of the whole country has established there, and Estonia is by far the most digital country when it comes to digitization of public processes in Europe. I'm from Germany, and I have to say Estonia, when it comes to digitization of public processes, is at least 5 years ahead of Germany, if not even 10 years. And you will tell us how to make this Gaia-X compatible. Your stage.
Yep. Thank you. So, hello everyone. My name is Petteri Kivimäki. I'm the CTO of Nordic Institute for Interoperability Solutions, NIIS for short. And I'm going to tell you about X-Road, that is a secure data exchange layer originally developed in Estonia, and how we are planning to make it data space compatible. So this use case is a little bit different, since usually data space initiatives are about building something completely new, but we actually already have several X-Road data exchange ecosystems around the world, and our challenge is how to make the existing ecosystems data space compatible. But first, a little bit of background. So about NIIS. NIIS is a non-profit association which mission is to develop digital government solutions to its members. And currently, NIIS has 3 members, Estonia, Finland, and Iceland. And we have 2 products, so X-Road, that I already mentioned, and Harmony e-delivery access. They are both open source solutions that can be used to securely exchange data between organizations. The main difference is that X-Road is for national data exchange, while Harmony is for cross-border data exchange between the EU member states. But today, I'm going to concentrate on X-Road. So first, what is X-Road? X-Road is an open source software and ecosystem solution that provides unified and secure data exchange between organizations. X-Road is licensed under the MIT open source license, and it's a digital public good verified by the Digital Public Good Alliance. Currently, there are at least 23 X-Road ecosystems around the world, and in the countries where X-Road is being used, there are over 540 million people living. X-Road community instead has over 3,600 members from 150 different countries. And this is how it looks on a map where X-Road is currently being used. As you can see, in addition to Estonia, Finland, and Iceland, X-Road is used in many other countries around the world. Interestingly, it has a very strong user base in Latin America. But as you can see, in Europe, actually Germany is also marked on the map Unfortunately, in Germany, X-Road isn't used on a national level, but instead there is one private sector use case. It's related to healthcare. If you are interested in learning more about that use case, please visit the X-Road website. It is documented there. Typically, data exchange ecosystems, they are implemented on a business domain basis. So when you implement a data exchange ecosystem or a data space, it's for some specific business domain or business case. X-Road is a little bit different. So usually when X-Road is implemented, it's implemented on a national level, and it's used by many different kinds of organizations, and it's used for many different kind of use cases and business cases. For example, in Estonia and in Finland, all the different kind of organizations use X-Road. Public sector, private sector, and when it comes to private sector, for example, healthcare, transportation, financial sector. So it's not just for one business domain. And that's, at the same time, it's also a kind of a challenge, since we are not developing a solution for one specific use case, but it has to work for many different kind of organizations and many different kind of business cases. When you look at X-Road on a high level, it has many similarities to data spaces, and actually you could think that X-Road is already a data space solution. But unfortunately, that is not the case, not today. So currently, X-Road is based on its custom protocol stack. So of course, many different standards and specifications are used in the implementation of X-Road, but any X-Road specific parts haven't been standardized. So all is basically custom. And those custom protocols are used when exchanging data within one X-Road ecosystem and when exchanging data between two different X-Road ecosystems. So X-Road already supports federation, so connecting different ecosystems. But of course, not the whole world is using X-Road, and data must be exchanged with organizations using other technologies and being members of other data exchange ecosystems. And that's where the problems begin. So currently, different kind of gateways, adapters, and so on need to be built for that kind of use cases, and it's not very sustainable. And when thinking about what's happening in the world of data exchange, it's becoming more and more common all the time. It's required to be exchanged data with different organizations, with different data exchange ecosystems, cross-border, and so on. And in order to do that without implementing the same thing over and over again, we need interoperability. And we see that the best way for X-Road is to be more interoperable with other data exchange ecosystems, is to become data space compatible or compliant. And our goal is to replace X-Road's current protocol stack with the data space protocol stack, meaning that we get rid of the custom stuff that we currently have and replace it with the specifications used by the data spaces. And it applies to the message exchange within one X-Road ecosystem, between two X-Road ecosystems, and of course between X-Road and other data exchange ecosystems that implement the same set of specifications. But as you saw from the map, we have many existing X-Road ecosystems around the world that are already using the software. It plays a critical role in many societies. which means that we cannot just implement this kind of a major change without thinking about backwards compatibility. And from my perspective, that's our biggest challenge when implementing the change. Because when we change something, it needs to happen in a backwards compatible way. And not only technically, but also when it comes to the operational processes of the existing ecosystems, because they already, since they are in production, they have their processes in place. So, but whatever we do, we need to be able to do it in a backwards compatible way. And that's where the biggest challenge lies. If we think about the data space protocol stack, it can be roughly divided in 3 different levels. So we have the trust plane, control plane, and data plane. When it comes to the trust plane, we are looking into the Gaia-X trust framework. Our goal is to be technically compatible and interoperable with the Gaia-X trust framework. In addition, X-Road will have its own trust framework too, but it will most likely be an extension of the Gaia-X trust framework. However, this doesn't mean that every X-Road user organization will be a Gaia-X participant. It means that X-Road provides the Gaia-X compatible technology so that the organizations, they may become Gaia-X participants if they want, and of course if they comply with the Gaia-X policy rules. Then on the control plane level, we plan to implement the data space protocol that is currently be worked on by the IDSA, and that should become an ISO standard later on. And then on the data plane level, there will be multiple X-Road specific data planes initially, at least REST and SOAP data planes, since they are the protocols that X-Road is currently using, but we already have use cases for many other data planes as well. But in order for 2 organizations to be interoperable, all these layers are required, and both organizations, they need to implement the same specifications on all the layers. And when it comes to the actual implementation, we are not going to reinvent the wheel, meaning that we code everything from scratch. No, our aim is to use existing open source solutions and components, for example, the EDC, the Gaia-X digital clearinghouse components, and maybe also the Gaia-X Federation services components. We take them as a basis and implement some X-Road specific changes on top of them. And of course, we want to collaborate in the development and also contribute to the upstream open source community. We have started to work with this approach in the beginning of this year, and the goal is to make the next major version of X-Road data space compatible. So the next major version of X-Road is X-Road 8, the spaceship. Currently, we are running a proof of concept which aim is to validate this approach. So is it feasible to implement this approach in a backwards compatible manner? The proof of concept will be completed by the end of May, and if the results show that yes, this is feasible, then we are going to continue with another proof of concept during the second half of this year. Next year, the beta version, and the next production version in 2 years in 2026. And like I said, we are going to utilize existing open source components in the implementation, and in general we are very interested in collaboration with other data space initiatives, whether it's about standards, specifications, or implementing open source components that support the specifications, because the best way to reach our goal is to collaborate and not reinvent the wheel. Thank you for listening.
Yeah, Petteri, thank you very much for this view into X-Road and your activities. One of the key enablers for trust in different ecosystems in Europe is eIDAS. Is X-Road also using eIDAS as it was created long before eIDAS was even established, I think? How is the situation here?
Yes, X-Road is using eIDAS. So X-Road was originally developed in, the first version was released in 2002, so a lot before eIDAS. But the current major version was released in 2015, so around the same time when the first version of eIDAS was published. And yes, X-Road is already using it, which is a very good starting point.
Yeah, exactly. And when I had a closer look at X-Road, it is a service-oriented architecture using a message bus, for example. Is it still the case that is it compatible with the data spaces we are actually building?
Yeah, it's, well, the basic architecture on a high level, it's still the same. Of course, we have developed some technical features further and so on, but the basic principle is still the same. And like I said during the talk, I think that there are many similarities already with data spaces. So I think that the path from the current state to the target state, it's hopefully not that long and difficult.
Okay, good. Are there any questions from the audience? I don't see. Now it's getting a bit brighter. No. Then, Petteri, thank you very much.
Thank you.
And it is now my pleasure to welcome Raphaela Butz on stage. Join me here from LMIS AG. Hello. And you will talk about AW 4.0, Autowerkstatt 4.0.
Exactly.
So what's Autowerkstatt in English?
That's a car repair shop or workshop or garage. It's not quite clear.
So let's call it Garage 4.0. And what's that about? That's your turn now.
Yeah. And thank you. So I occasionally ask myself if it's just me who gets a tiny bit distressed if my car pings me with a message telling me I need to see the next repair shop with some mysterious message I don't understand. And we already discussed this, so car repair shop is the project name of our project. And maybe I get so distressed because once my AC broke down, I went to the repair shop, I got it fixed, drove back happily in my well-tempered car, and of course, 1 year later, my AC broke down again. And I got to the repair shop again, I got it fixed again, and sure enough, 2 years later, my AC was broken yet again. That continued, no one really knew why, so every year or every other year, I went to the repair shop, and the issue finally got fixed, but by myself because I bought a new car. And there are now a lot of people having the same issues with their cars and need to go to the repair shop multiple times because some elusive issue that no one really seems to fix or can fix. And that is part of our use case, AI-assisted fault diagnosis for car repair shops. And the story I just told is the flip coin of the component-based use case we have, because usually if you need to go to the repair shop several times, it's because the wrong component was changed and not the actually faulty one, which means that the car repair shop doesn't only waste a component, but also the car owner's patience. But they don't do this on purpose, so they don't fix or they're of course trying to fix your car, but sometimes the car always tells you just the issue you have, but not how to fix it. And some issues are really, really hard to fix and to figure out, so the workshop just makes an educated guess because it's way more efficient than really figuring out which component is actually faulty. And you would need to interpret several voltage diagrams under certain circumstances, and these voltage diagrams are different for basically each car. So you would need a lot of knowledge, and AI-assisted fault diagnosis can help there. And I already said that they make educated guesses, so they are guessing which component most likely is the faulty one. Sometimes they get it on the first try, sometimes they don't, but you still need a skill to know this. And educated workers are getting sparse, and this knowledge is getting sparse and sparser, if that word even exists. And with that, AI-assisted fault diagnosis can help as well. And the last use case we have is avoiding data silos. That's Gaia-X 4. And because if you have a look at this slide, here we can see a big data silo here at this organization. And in a centralized system at this abstraction level, that's an easily told story. We have several repair shops, and with them you can collect data. With this data you can train AI models for diagnosis, and with using this diagnosis, car repair shops are gathering data again, which then again can be used to make even better AI models. But here we have a big dependency on this one organization. And in reality, it's even super hard to actually gather this data. So this one organization would need to put a lot of resources and efforts into gathering this data on its own. So like Ulrich mentioned this morning, we would like to have not a few to one, but a many-to-many network. But how can we achieve this in a data space? And here, this slide is probably the most generic data space you ever saw, but already at this abstraction level, we needed to ask us a lot of questions. Because car repair shops are probably not that interested in data spaces. They want to fix cars efficiently. So how can we empower them to be sovereign in a data space, especially independent repair shops? And what does this even mean? And how can we ensure that they just need or can share data with organizations they actually want to share their data with? How can we ensure that they can use diagnostic models from several organizations and still use one diagnostic system? Can we do any sort of edge deployment for this organization, but still using the data space and still keeping the car repair shop sovereign? And we found a very unique solution to that. We totally didn't. We use EDC as a service. But there's, of course, more to the picture. So, namely our hub. What we do in there is, and of course, the EDC does a lot of legwork when it comes to trustworthy data exchange. And the data spaces here is on purpose because you could also decide to expand your hub with another connector if you want to participate in another data space, as Roland mentioned this morning as well, that you can connect different data spaces through users. So and that would be an opportunity. Let's pretend there would be a data space interested in a circular economy, in mobility, or interested in the component lifecycle. Then the workshop could decide to join this data space as well with the connector they have. And the other part, our software as a service part, ensures that these workshops have one diagnostic system, but still can use AI models from different organizations in one hub. And since it's Dockerized, you have some flexibility in hosting. How do we ensure that these diagnostic systems can be used? That's because we have a lot of logic behind it, a lot of ontologies, telling you which symptoms, which OBD data, if you know what that is, most likely leads to which faulty component, which components interact with which other, which faulty components might even cause issues in other components. So we have this logic in our hub that you can add AI-assisted fault diagnosis. And you can also use your usual testing systems you already have in your repair shop for like measuring voltage data and upload it to the hub. Or if you want to have the full experience, you could choose to use our device X, which is developed in this project. And I just realized we're probably naming things isn't our strong suit. So the device X has a very small oscilloscope in there, which is measuring voltage data and has a display, and is there for visualizing voltage data, but it also has the whole hub integrated. And with that, I would open the floor for questions, but you can also, if your question is unanswered or you want to know more about the hub in more detail, you can meet us after this panel or from 3 p.m. till 4:30.
Yeah, thank you, Raphaela. Today's cars are producing a lot of data, which are very interesting for the garages, be it OEM-related garages or these independent garages. How are the regulations so far to provide access to this data also for independent garages? What is the status here? I think it's a highly political topic because the OEMs, the original equipment manufacturers, would like to keep the data for themselves and not to provide it to independent ones.
Exactly. Thankfully, that is not our use case because we are concentrating on voltage data. Since that's not, well, the last info I had, it's not very clear politically if they now really need to share this data. And for now, we are using voltage data, which isn't really used in the manufacturers. It's like the OB data they don't want to share because there is a lot more information a car can give you if you are not independent but are one repair shop from an OEM. And we don't access this data right now, so we are really trying to figure it out with the data they need, they have to share, and then use voltage data for the rest.
Okay. Are there any other questions from the audience? None. Then, Raphaela, thank you very much.
Thank you.
I'd like to take this over. So, coming to our next presentation, SmartMA-X, Smart Manufacturing X, as a pioneer for Factory X. Factory X, an initiative in Germany, and we were expecting Pascal Rubel here on stage. Pascal is team lead at the DFKI, the German Research Institute for Artificial Intelligence. He is project lead Factory X, and he is a project lead of the SmartMA-X project. But he's sick. So he gave us a message this morning that he's not able to come, and therefore I will step in and explain to you what is Smart Manufacturing X based on. I'm able to do so because I had the pleasure to visit them 3 weeks ago in Kaiserslautern, and I was really impressed of what they are doing there. They is the association called Factory X. It was established nearly 20 years ago, so 2005. It's a non-profit organization. The CEO is Professor Martin Ruskowski, together with a team. They have members from more than 8 countries and working on digitization on the shop floor level, on improving the productivity of factories and supply chains. You see a list of their members. Membership in this Smart Factory KL. KL stands for Kaiserslautern, the city in the southwest of Germany, where it is located. And the business drivers which were there already 20 years ago when they created Factory X is disruption in supply chains. And we are experiencing this more and more in our daily life, that supply chains are interrupted, that transportation chains are interrupted due to strikes, due to canals which are blocked, and really interrupting the whole production process. Then this customer individual products or lot size 1 requires very flexible production facilities to be able to do so. They need to react shorter to the market requirements, so to reduce the time to market. And Factory X is aiming to utilize open capacities. So when a factory, a plant has capacities which is not used for the own production processes, why not provide this to other customers? And the digital supply chain is, now I fall into the same track, the digital supply chain is supporting this on the supply chain level, making the supply chain more agile. On the factory level, being able to adopt it to the customer requirements, down to the shop floor level, to the machine level. And here it is. And this is finally the vision of the Smart Manufacturing X project. It is a project belonging to the manufacturing cluster funded by the German government. And the vision of SmartMA-X is the establishment of distributed production in Kaiserslautern according to Gaia-X principles in order to be efficiently and sustainably equipped against external influences, so to make manufacturing more resilient. And to be able to do so, the shared production identifies supply chains at runtime. On the left side, we see a development engineer on his CAD system, his computer-aided or her computer-aided design system, and using a shared production platform to identify production capabilities in a supply chain, in a flexible supply chain, to produce the required project. And that can be different steps in a flow of production facilities. And data spaces are enablers for this shared production. We have a digital representation of the product on the one side. So how does, for example, this product looks like? What is the bill of material? What are the different parts in here? And we have, on the other hand, companies which are providing production capabilities. And also these production capabilities have a digital representation. They are described. And finally, we will have a matchmaking. Here, Gaia-X-based matchmaking to bring the demand on the one side and the production capabilities on the other hand together. So this is the approach of SmartMA-X. It is based also on the Industry 4.0 concepts. So the so-called asset administration shell and an according API is used here to bring on the left side the service requester and on the right side the service providers together with a connector. And you can see on the left side here the production description. So what's required, it is transferred to the service provider, and finally the production is done. And they are not only doing this theoretically, they have really created flexible production cells, and the product they are producing is a truck. the size of a Lego truck, but it is really produced in production lines, and the process here is that the different service providers are providing an offer, as you can see here, and this is then included in a service description, and I will come to this overall model, and here this is the final one. The communication is using the Eclipse data space connector. You've heard about EDC before. It is one of the connectors which is based on the IDS reference architecture model, where the IDS connector is described. And EDC is one of the possible implementations of this concept. There are others in place. Yeah, TNO has done one, VTT has done one. The 5-Air data space connector is another implementation, all based on the reference of IDSA. EDC is broadly used in Catena-X, but also in other projects, like here in the SmartMA-X project. And you see, it is the enabler for the interoperability between the different partners. And that's it, I think. Sorry. I thought these were grayed out. If you would like to have further information on this one, you can go to Smart Factory, and there are also information for the project SmartMA-X and videos there describing it. And really, I was impressed when I visited their location in Kaiserslautern. It is a very open building, a complete glass front to the street, so they are open to the public and producing there these trucks and having this as a showroom for flexible production cells which can be configured quite rapidly. And that's the presentation of Pascal Rubel, and here you can see how he would have looked like if he would have been here. Okay. Any questions on this one? Or any general questions on this session we had on successes using Gaia-X based technologies? Bert, the microphone is coming to you.
I would be curious also for the business model anticipated for the last two data spaces. Who pays for this service?
Yeah, where's Raphaela? Still here? There's a microphone. Maybe you can use the microphone. So in your case, who is paying for this service you are creating?
So who asked the questions? Here, okay. So we are planning to do a value chain, actually. So the very broad idea, or on a high abstraction level, would be that the car repair shops pay for the diagnosis, and the people making the diagnosis pay for the data, of course, they want to do the diagnosis with. So repair shops provide data, and with this data you can AI models, and this AI models can again be used for repair shops. And yep, we do have a little problem with a cold start here. I am aware about that, so we're already trying in our use case to make at least one very valid diagnostic model and try to onboard more people who are already having a diagnostic models. And when it comes to business cases, there are a lot of other business cases for operating the data space as well and interacting with it. Is that fair enough? Fair enough, okay. Fair enough.
Yeah, and Bert, on this manufacturing part, to give you one example, I'm aware of in Germany, there are several production companies which are providing services in the so-called area of additive manufacturing, also known as 3D printers. Yeah, plastic, but also in metal. And there are really production companies who are just doing 3D prints as a service. Different companies. And they joined their forces, created a marketplace for 3D production capabilities. So if you have a 3D model, and I think it's called STL file, where this 3D model is described, you can put it onto this marketplace, get offers from different production service providers, and can select it. And the business case behind it is that this marketplace is operated and financed by the providers of this production services. Yeah, as one example. But it's a very valid question because without an underlying business model and without an idea how to earn money with data spaces, such data spaces are not sustainable. We are in a situation that a lot of also the Gaia-X based lighthouse projects are pre-financed by public funding, be it from the European Commission, be it on member state level, or be it even privately funded from organizations. But to be sustainable after the creation of these data spaces, when the public funding ends, it is important to have a sustainable business model. And the session we had before the break on the Gaia-X Institute is exactly an approach also to work on this and to create sustainable business models for sustainable data spaces. Other questions? There's one over there. So close to the microphone.
Thank you. So maybe it's not fair to direct that question to you as you...
If you, as not everybody knows you, if you would just introduce yourself.
I'm Michael from the Mobility Data Space.
Thanks.
I'm wondering what's the difference, or how do Factory X and Manufacturing X relate to each other?
As I think it was shown on one slide that SmartMA-X is a kind of seeing itself preparing for Factory X, and to get you all on board, there are different waves of, I need to go into the light, different waves of funding of Gaia-X based data spaces in Europe and also in Germany. You have created, you are one of the pioneers, with a mobility data space in a very early phase. Then there were 11 projects funded by the Ministry of Economic Affairs, and SmartMA-X is one of these projects, so it's already ongoing, and it is preparing the adoption of Gaia-X based solutions and data spaces in the manufacturing domain. And now we have a new wave of funding which is Manufacturing X, with the ambition not only to do it in Germany, but to do it from the very beginning as an international or even global initiative. And we will talk about IMX during these 3 days, the International Manufacturing X initiative. And one of the projects within this frame, but I think they don't have received their formal funding agreement yet, but it's quite clear that they will be funded, is called Factory X. It is quite a big one, and Factory X, if I position it very simple, has the ambition to transfer what's been developed in Catena-X, and a lot of you have heard about Catena-X, to the remaining part of the manufacturing industry, or at least to the discrete manufacturing industry. Catena-X is very much focusing on automotive industry, and the rest is then addressed by Factory X. And SmartMA-X, as it is an ongoing project, is preparing this. And we need to see how many of the results of SmartMA-X are reused in Factory X, and how much collaboration will be established there. But therefore, it is important to know of each other, to know the results, and to share the results in conferences like we do here in Darmstadt. Any other questions, comments? That's not the case, so we will go into the lunch break now, 8 minutes earlier than scheduled, but looking... Okay, that was Siri. Looking at how many traffic is outside at the exhibition booth, take a lunch and use the time to visit the exhibitors, use the time to meet new people, and use the time to exchange your opinions, your views, and your experiences. So thank you very much for the morning, and see you after lunch break.